Okay, so next is circular coil. So circular coil, the formula that we use is to determine the magnetic field intensity, magnitude of magnetic field intensity B at point O, or the center of the circular coil by given equation B equal to mu naught Ni over 2R. Okay, mu naught is same as before, is 4 pi times 10 to the power of negative 7. N is number of turns, I is the current flow, 2R is the radius of the circular coil. Radius of the circular coil. So B ni adalah magnetic field intensity. So ni adalah radius, ni adalah diameter kan. So radius means here. Okay. Alright. So let's try this. We have circular coil has 50 turns, 15 turns, and the diameter of the circular coil is 45 cm. The magnetic field strength at the center of the coil is 8 times 10 to the power of negative 4 Tesla. Means that B. Find the current flowing in the coil. So by using formula of the coil, circular coil B equal to mu naught Ni over 2R. So substitute the value. So we get the current is 19.1 ampere. Okay, make sure all the unit you have changed in SI unit, because the unit for B here is Tesla. Tesla means dia punya SI unit. Okay, so next is next example. We have two circular coil with radius of 20 cm and 40 cm are placed with their center at point P. If the current flowing in the same clockwise direction, this is clockwise direction. So what you can see here, the coil have 0.5 ampere and 0.8 ampere respectively. So calculate the resultant magnetic field at point P. Okay, so bila kita lukis, kita label lah I2, so I1. Logik lah, I1 ni nilai dia adalah radius dia 20 cm, lagi kecil daripada 40 cm. Okay, so bila kita lukis macam ni, direction current is clockwise. So kita akan dapati direction of P adalah into page. Okay, ni saya dah ajar kan macam nak cari P. So hari ni kita nak kira. Okay, so B1 is equal to mu naught and I1 over 2R1. So substitute the value. Alright, so we get 1.57 times 10 to the power of negative 6 Tesla. So adalah into page. For B2, substitute the value. You get 1.26 times 10 to the power of negative 6 Tesla. Also into the page. So the resultant of magnetic field at point P is given by B1 plus B2. So you get 2.83 times 10 to the power of negative 6 Tesla. Direction is into the page. Okay, for solenoid is an electrical device in which a long wire has been wound into a succession of the closely spaced loop with the geometry of helix. Okay, itu beza dia dengan circular coil. Kalau circular coil dia hanya satu round sahaja, tapi kalau solenoid it made from the banyak round and then dia berbentuk sebagai helix. Okay, so macam ni lah. Alright. So the magnitude of magnetic field intensity at the center of the mid ataupun at the midpoint of the solenoid, kita bagi equation ni B equal to mu naught Ni over L. L ni adalah length of solenoid. Ni solenoid kan? Ni length of solenoid. Jangan salah faham. Ni length of solenoid. Ni adalah formula. Length of the solenoid dengan length of the wire tak sama. Length of the wire yang produce, contoh length of, you ada satu length of the wire. Ni length of the wire, and then bila kita woundkan length of the wire to produce solenoid, maksud kita gulungkan length of the wire ni, kita akan jadi length of solenoid. Tak sama tau. Okay, alright, so here is represent N over I. Dia boleh juga tulis B equal to mu naught small n I. Small n means that number turns per unit length. Ada juga dalam soalan dibagi n kecil kan. So nak tahu guna n kecil dia sama dengan n besar bahagi L. N besar adalah number of turns per unit length. Itu adalah small n. Okay, so next is magnitude of magnetic field intensity at the end of the turns, at the end of n turns of solenoid. Maksudnya di hujung. Okay, macam tadi formula untuk tengah-tengah. B equal to mu naught Ni over L. Tapi kalau di hujung, you kena bahagi separuh sebab dia rasa separuh sahaja. Okay, so you boleh juga tulis B is equal to half mu naught n I over L. Sama je. Okay, so ini dah bagi tahu lah. N over L sama dengan small n, where small n is number of turns per unit length. Okay, so kita tengok example. So let's try this. We have solenoid is 50 turns, is carrying a current of 10 milliampere. So the magnetic field strength inside the solenoid is 1 times 10 to the power of 5. Sorry, 1.05 times 10 to the power of negative 6 Tesla. Calculate the length of the solenoid. So length of the solenoid is here. So calculate the value by using equation of the solenoid. Okay, so we get length is equal to 0.598 meter. Okay, boleh ya? Right, so next we have a solenoid length of 2 meter and 3.8 cm in diameter, carry a current of 16 ampere. Then magnetic field inside the solenoid is 2.3 millitesla. Calculate the length of the wire forming the solenoid. So this is the difference between length of solenoid and length of the wire. Wire that produce the solenoid, but our formula used length of solenoid. Okay, bukan length of the wire. Jadi you kena faham. Okay, so this equation, by given information, so we can determine the number of turns for this solenoid. Okay, number of turns is 228.79 turns. Jadi kita hanya ambil 228 saja. Even though you punya nilai lah 228.99, so you still ambil 228 juga. Okay, so number of turns yang kita dapat kira lah 228. Okay, then nak cari length of the wire macam mana? Okay, length of the wire, kalau kita tengok, kita boleh tahu, kita boleh kira dia punya muka bulatan ni based on circumference. Okay, circumference ni kena kali berapa banyak turns yang dia boleh dia boleh buat. Okay, so L, length of the wire, we can determine by circumference punya formula 2 pi r times with number of turns. So 2 pi times with radius. Radius ni 2 pi r circumference and radius 1.9 times 10 to the power of negative 2, and then times with number of turns 228. So we get 27.22 meter.